Hi everyone, we're going to talk today about the properties of real numbers and also something called combining like terms. We'll do at least one lesson on this. There might be a part 2 tomorrow, but once we get the hang of this, not too complicated. So the properties of real numbers, these are some things you should have probably heard of in earlier years. The properties we want to talk about are the commutative property, the associative property. The big one for us today is the distributive property, and that's probably the biggest one we use in Algebra 1 all the time. We've talked about the multiplicative identity property. When we multiply something by 1, we get itself, or the additive identity when you add 0. We'll talk about this inverse property a little bit later when we're solving equations. So commutative, associative, and distributive properties are the big ones for us. And as we can see in this chart, we have them written out kind of algebraically here, and I want you to get in the habit now of starting to see things written with letters instead of numbers. Commutative property you've heard of in elementary school. It means when we add things together, we can add in either order. 7 plus 5 is the same as 5 plus 7. Or 7 times 5 is the same as 5 times 7. So we have a commutative property for multiplication and for addition. I want you to think about whether or not we have one for subtraction or division. Is there a commutative property for subtraction? In other words, can we subtract in either order? Can we divide in either order? Think about those things. Justify them with your mind. Think of a couple of numbers and decide if there's commutative property for subtraction and division. Next property we talk about is called the associative property, and that's a grouping symbol, a grouping property. You see these parentheses in with the associative property. When you see those parentheses, think associative property. What it says is that if we have 3 things to add together, it doesn't matter which ones we add first. Technically in math, we can only add 2 things at a time. So if we see 3 things added together, we think about adding 2 of them and then adding the third one in. But the associative property says it doesn't matter which 2 you add first, you're going to get the same number. Same thing with multiplication. We multiply 2 things together, then multiply by the third one. Or we could multiply those first 2 things and multiply by the third one. They're equal. That equal sign in there means that it doesn't matter. We get the same result, the same value either way. The distributive property is the important one, the new one maybe for some of you. Distributive property says if we take something like 5 times 7 plus 3, order of operations would tell us to do inside the parentheses first. That would be 5 times 10, which would be 50. But the distributive property tells us we can also multiply the 5 times the 7, which is 35, and then add the result of 5 times 3, which is 15, and we still get 50. When we talk about the distributive property, it's multiplication across an expression. And again, notice there's no operation in there. It's assumed it's multiplication. Okay, distributive property always involves multiplication. These are some quick examples from your book of why we have these things and why we use these properties. First one here says negative 12 plus 67 plus 12 plus 23. In your brain, you're saying minus 12 and plus 12, well, that's 0. So now I can add 67 and 23 and get 90. You've just used the associative property and the commutative property together. You didn't even think about it, but that's a thing. Okay, so we have these properties that says it doesn't matter what order we multiply or we add in. If we have a problem like this one with the 1/3 times 8 times 21, 1/3 times 8 is not easy to do, but what if I rearranged that and wrote it as 8 times 1/3 times 21? I just used the commutative property to switch the 8 and the 1/3 because it's really easy to multiply 1/3 times 21. 1/3 of 21 is 7, times 8 is 56. Okay, so it's some things you've been doing in your brain all along. They just happen to have names. Okay, so commutative property, associative property. At the bottom here it says write each product using the distributive property, then simplify. I don't do this very often because I can't keep numbers in my brain very well. But if I were to look at a problem like 9 times 38, some people might say that's the same as 9 times 30 plus 8. And that's 9 times 30, which is 270, plus 9 times 8, which is 72. And then if I add those together, I get 342. But again, I'm not great at holding things like that in my brain, so I don't do it that way very often. But the possibility is there. For this number 13, I could say that's the same as 7 times 100 plus 0 tens plus 9, or 100 plus 9, would be 700 plus 0 plus 63, or 763. Okay, so the distributive property is, it's a way to make some multiplications or some things easier for us sometimes. All right, but here's the new stuff, the algebraic part of the lesson that I want to talk about. It says the directions here: simplify each expression by combining like terms. The terms in an expression are the things, the parts that are added or subtracted. They might be numbers, they might be variables, they might have exponents, but it's the things that are being added or subtracted are called terms. Like terms are the terms that contain, they have to have the exact same variable part raised to the same exponent part. And then it's just combining them together, like black jelly beans combined with black jelly beans and pink jelly beans combined with pink jelly beans, but black jelly beans and pink jelly beans don't mix together. So if I'm looking at this first problem, 6x plus 10x, I have 6 x's, I'm adding 10 x's, I get, guess what, 16 x's. The next one, 35x minus 15x. I have 35 of these things, I take away 15, I have 20 of them, 20 x's. Number 16, I have negative 3 a's and I have 9 a's, and if I add those together, I get a total of 6 a's. We want to pay attention to our signs. So here's where the signs that we talked about early in September come in. Minus 8r, that's minus 1r. The coefficient of that letter is, of that variable is a 1. Gives me minus 9r. Number 18, I have 17x squared plus 1x. These are not like terms. The x squared is a different term from the x. The variable part has to be exactly the same, and the exponent part has to be exactly the same in order for them to combine. So my answer here is 17x squared plus x. That's it. It can't be simplified anymore. Down here at the bottom, we're going to simplify, and it says justify each step with an operation or property. I'm going to just talk you through these. You don't need to write these down. But the first thing I want to do is distribute, and then I'm going to combine like terms. So in number 20 here, if I distribute that 5, that would be 5x plus 15 minus 7x. So I've used the distributive property, and now I'm going to combine like terms. 5x, and here's what I need to be careful of. The sign is the sign that comes in front of the term. So 5x minus 7x becomes minus 2x plus 15. You may have written that as 15 minus 2x. Those are the same thing. I would accept either answer. Generally in math, we start with the variable term, but it doesn't really matter that much. So distribute, combine like terms, and the trick here is watching your signs at all times. Let me look at number 21 here. Again, distribute and combine like terms. That would be 9a minus 27. Again, we're multiplying across those parentheses. Minus 4 gives me 9a minus 31. So I do have some like terms here. And part of the practice here is getting used to what's a sign and what's an operation. Is that 27 being subtracted or is it negative? And it's really interchangeable. It could be either one depending on the context of what you're thinking about. All right, let me do a couple more here because the signs are important. Again, thinking about signs. Number 22 tells me I have 5x squared minus, and again, I'm distributing across the parentheses. I'm multiplying across the parentheses, watching my signs carefully. That's minus 2. So I'm going to forget that 5x squared is there. And I'm going to think of this as though it's a negative 2. Minus 2 times x is minus 2x. Now it's minus 2, forgetting that x is there. I've taken care of the x. Minus 2 times minus 3x squared is positive 6x squared. So again, the signs are important here, and this is where we fall into trouble early in Algebra 1 is getting used to these signs, and we'll practice these a lot. Now I want to look at this expression. Do I have any like terms? Well, let's see, here's a 5x squared, and here's a 6x squared. Altogether, I have 11x squared. And again, that minus 2x, not a like term. 11x squared minus 2x would be my final answer. And I'm going to have you hit pause right here. Try number 25, and then come back and check and see if you got the same answer as me. Okay, so hit pause. Try this one, watching your signs carefully. All right, and here's my final answer. I distributed that minus 2, and I got 4a minus 2a, and then plus 2 again, because that's a negative 2 times a negative 1 gives me a plus 2. And then I combined the like terms and got 2a plus 2. So these are sign issues more than anything else. It's not complicated. This might be the first time some of you have seen distributive property, and we're just going to practice these. All right, so we'll practice, practice, practice. So I'm going to have you go into your book or check the link that's up in the chart. We've done some of these problems already, but pages 49 and 50, you're going to do numbers 14 through 25, and then 34 through 43. And give those a try. Okay, watching signs, again, is the most important point with this lesson. All right, and we'll talk to you tomorrow.